Hello and welcome back. In the last video, we went over using y is equal to mx plus b to sketch different types of linear functions. In this video, we're going to do the same thing, except we're going to work with slopes as fractions and as negative numbers. So this first example over here, I have y is 3 over 2x. So the first thing we do is always look at the y-intercept. And in this case, there is no number after the x. We therefore would say that the y-intercept is 0. If it helps, you can pretend that there is a 0 that comes after the x by just writing in plus 0. But yeah, because there's no number after the x, we would therefore state that the y-intercept is 0. And we would therefore we would look at the y-axis, look for y is equal to 0, and plot that point. And the next thing we need to do is calculate the slope. So the slope in this case is given by 3 over 2, because m is 3 over 2. And we also know that the slope is rise of a run. So we compare 3 over 2 with rise of a run, and we see that the rise is equal to 3 and the run is equal to 2. And we can go back to our graph, and since the rise is 3, we know that y increases by 3, so we would sketch that. And since the run is 2, we know that x increases by 2. We would sketch that, and we could write in 3 and 2. So y increases by 3 and x increases by 2. And we can then plot the next point using this triangle that we have created and form the line. And so that would be the line for the equation y is equal to 3 over 2x. The next example I wanted to go over was an equation with a negative slope. So in this case we have a slope of negative 2. So the first thing we would do is find the y-intercept. In this case, the y-intercept is 3, because b is equal to 3. And we could write that as a coordinate 0, 3, because we know that any point on the y-axis has an x value of 0. So we would look at the y-axis, look for y is equal to 3, and plot that point. And the next thing that we would want to do is find the slope. So in this case, the slope is negative 2. Once again, we know it is also given by rise of a run. And remember from the previous video that I talked about how if you have the slope as a whole number, it is very useful to write that as a fraction. So in this case, we can write that as negative 2 over 1. That's still negative 2. We've just written it as a fraction, because from here we could say that the rise is negative 2 and the run is 1. Now let's just pretend that the rise was 2 and pretend that there was no negative sign, that we just had 2 over 1. If that was the case, we would write a rise of 2, or y increases by 2, and a run of 1, or x increases by 1. But in this case, the rise is negative. If that's negative, that means that y is decreasing rather than increasing. So we would therefore say, looking at the graph, that y decreases by 2. So we have that rise is negative 2, run is negative 1. If y decreases by 2, we show that on the graph, and then we show that since the run is 1, x increases by 1, and so we can label that negative 2 and 1. And then we can plot the point at the other end of the triangle, as we normally do, and connect the points to form the line. And now we have the line of the equation y is equal to negative 2x plus 3. So once again, if you have a negative slope, that means you have a negative rise. And so rather than y increasing, you have that y decreases. Alright, so now that we've done an example with positive and negative slopes, I think it'd be useful to go over the general difference between those two kinds of slopes. We can create an example function over here, y is 2x plus 1, and plot this on a graph. And we notice that it has a positive slope, which means that it increases from left to right. So these next two lines also have positive slopes, because they all increase from left to right. And I think it'd be helpful if we compare this with negative slopes. So again, we could use an example equation y is negative 2x plus 3, and we can also graph two other equations that have negative slopes, and we notice that they all decrease from left to right. So once again, graphs or linear functions with positive slopes increase from left to right, while graphs or linear functions with negative slopes decrease from left to right. So that's all I had to say in this video. In the next video, we'll do a brief intro to steepness. But for now, thanks for watching.